are some quick tips and quick things to know when it comes to multiplying fractions together. Some quick tips. We're going to look at a situation where we have something like this. We'll have one where we have a whole number times a fraction. Uh, and we'll look at another one. Let me write it down here. Another one of this form, let's see, like this. All right, so let's look at these. When multiplying fractions, right, you just multiply them straight across. You just multiply them straight. So this would be like just a 3 times 1, which would be a 3, and then a 2 times 2 is 4. That's just it. It's just straight across. There's no special effects. There's nothing. Right? Let's take a look at this one. Right? This is straightforward. 2 times 3 is equal to 6, and 3 times 4 is equal to 12. Right? So it's straight. Just 2 times 3, 6 in the numerator, and the denominator, 3 times 4 is 12. But you can see over here that this can be reduced because there's a little relationship going on between the 6 and 12. So they can be reduced. I can find the greatest common factor between 6 and 12. Pretty much it's going to be 6. And so it's going to be 6. It's going to be 6 divided by 6. And it's going to be 12 divided by 6. And that's going to be equal to 1. And then 12 divided by 6. That is equal to 2. So that's going to be the answer. There's something you can do with these fractions before going through all of this. Well, actually, by manipulating these fractions here, by looking at the relationships between them, you don't have to do all of this. You can go from this all the way to this final answer here. And how we do that is this. I'm going to rewrite these to take a closer look at them. Anytime, when you're dealing with fractions, especially multiplication of fractions, the numerators and the denominators, they can cancel each other out. You can start simplifying right there and just start canceling things out. For example, I have a 3 up here and a 3 down here. Because it doesn't matter, when you're multiplying, as long as you have something up here and down here and they're kind of related, they can start canceling each other and reducing straight from there. Like for example, the fact that I have a 3 up here and a 3 down here is almost like saying 3 divided by 3, which is 1. So they're going to cancel each other out to be just 1. It's going to be a 1, right? And now we're going to be left with pretty much this 2 over 4. And then I can look at the 2 over 4. I can look at that 2 over 4 and see that that can be simplified or canceled, right? Because there's a 2 in here. 2 times 2 is 4, and then here's a 2 here. So one of the 2's in here can cancel with this 2 here. If you really think about it, right? This 4 is made up of 2 and 2. That makes this 4. And then we have 2 here. So one of the 2's can cancel with this 2, leaving this 2 alone, and pretty much a 1 here. So I will erase this. So we're left with a 1 up here and a 2 down here. So it's the same answer. So what I just did here is, just by looking at the fractions, I was able to do some kind of canceling or reducing right then and there before doing our multiplying. So that's what I did down here, and I got 1 over 2. I'll do some more examples. Whenever you have a situation like this, where you have this whole number multiplied by a fraction, I think I should use a different example, but I will use this. Think of it like this. This is how I imagine it. Think of it like this. The whole number is always up here, right? It's always up on top with the numerator. So you can see this big whole number looking like this. I look at it like this. So I know these can cancel each other. These cancel each other because it's pretty much a 9 divided by 9, leaving the 8 alone with a final answer of 8. So pretty much these cancel each other, um, which makes an 8. 8 times 1 over 2. Now this one, there's some kind of canceling that can go on here, right? I remember back when I was younger, I had no idea what was going on. Teacher would do this and do that, and I had no idea what. But see, what's going on is here. You have a 2 here, and you have an 8 up here, because the 8 is kind of like you can look at it as being up on the numerator, similar to this. The 9 was up here beside the 8, so this 8 is up here beside the 1. This 8 is made out of 2 and 4. 2 times 4 is 8, right? And here's the 2 here. So the 2 that's inside this 8 is actually canceled out with this 2, leaving the 4 hanging here. See, if it makes sense, this 8 is pretty much, this 8 is pretty much a 4 times 2. And it's that 2 that's canceled, but I just crossed out this whole 8. But this really is the 2 inside this 8 that's canceled with this 2. So they cancel each other. So I'm going to have a 4 up here times a 1. That's what I have left. I pretty much have a 4 times a 1. And that's just going to equal 4. An example where you have a 2 as a whole number times a 3 over 2. These two cancel each other out. The 2 up here and the 2 down here cancel each other out, pretty much just leaving the 3 alone. Let's think of some more examples. This time I'll put some parentheses. It means the same thing. Say 1 over 2 times 5 over 7. I would look at this and say to myself, there's nothing that can be canceled, nothing in this. So this is just going to be a straightforward, just multiply straight across. So it's pretty much the 1 times the 5 is 5. And the 2 times the 7 is 14. There's nothing that can be done, nothing can be reduced, simplified or anything. That's just straightforward. If we throw some negative numbers into the mix, or some sign numbers, I'm going to use the same numbers again. Now this is where we tap into our signed rules. This is why it's very important to understand the rules with signed numbers. Multiplying, adding, dividing, subtraction of signed numbers. This is why it's very important. Because if we have a situation like this, now I have to think, I'm going to be multiplying fractions, so I'm going to have to turn on or I have to put on my multiply fractions hat, and I also got to put on my sign numbers hat. So I have to consider two things, right? I got to put on these hats on my head. I'm just, imaginary hat, where I'm going to have to think, what are the rules for sign numbers, multiplying sign numbers that are the same, and what are the rules for just multiplying fractions in general? So by looking at this, I can clearly see, it's going to be this, right? It's going to be because it's you just multiply straight across, and we have the multiplication of the same sign is going to be positive. Remember, the multiplication of the same sign is positive. It's going to be positive. Although both signs are negative, your answer is going to be positive. Had we have it like this, for example, so let's say we had it like that, where it's a negative 1/2 times this positive 5/7. It's going to be regular multiplying across 1 times 5 is 5, 2 times 7 is 14. But here's the multiplication of different signs. So your answer is going to be a negative. This is going to be a negative fraction. So you're going to see things like this. And you just have to keep in mind of your signs. Should we do some more? I will do another one this time where we can reduce also. So we have a negative 2 times, let's say 15/8. So we have a multiplication of unlike signs. So right there, I know my answer is going to be negative because we have a multiplication of unlike signs. We have a negative 2 and a positive 15/8. So now I got the signs out of the way. Now I'm going to look at just the multiplication. So I have this thing going on here, and say to myself, okay, there's a little relationship with 2 and 8. Something's going on here, right? Because I know 8, to get 8, 2 times something is 8. And here's a 2 here. So we can do some kind of canceling, right? Because this 8 is pretty much made up of 2 times 4. Right? This 8 is pretty much 2 times 4, and here's a 2 here. So this 2 cancels out with this 2, leaving the 4. Right? So we already have negative. So our final answer is going to be 15 is all by itself up there, and then we're going to have 4 down here. And that's the answer. So it's pretty straightforward when multiplying fractions. And I will stop right there. That's it. We will go on to dividing fractions.